All right, let's graph number 5 together. I want to know the power term. So we have x squared times x. I'm just going to put that together. That's x cubed, which means the right end is going up and the left end is going down. I want to find the intercepts. Again, you can press pause at any time. So we're going to find the power term, which gives me the ends, the intercepts. So the x-intercept. So positive 1 and negative 1. Positive 1 has an even exponent, so it's going to bounce. And then at negative 1 has an odd exponent, so it's going to cross. The y-intercept, not 0. Plug in 0 to find it. So if I plug in 0 and I'm careful, negative 1 squared is positive 1 times positive 1. So the y-intercept's at 1. All right, we're ready to graph. So I'll start. I think we have everything we need. We have positive 1, we have negative 1, and the y-intercept in the middle. I'm not plugging in any fractions in here. Like, that's all we need. So we found a number in between the intercepts. It's there. I think we're ready to go. We know the right end goes up and the left end goes down. Connect the points, and it bounces at positive 1, crosses over, and we're done. Last thing I want to write down is understand the maximum and minimum. So we have a relative max at 0 and 1, and we have a relative minimum at 1, 0. And that's it. All right, number 6. As always, you should always try it first. But I'm here for support. The power term. X cubed times x times x. Add the exponents across, and it's x to the 5th, which means the right end goes up and the left end goes down. So we have the end behavior. The intercepts, the x-intercepts are negative 1, positive 1, and positive 3. All of them have odd exponents, so all of them are going to cross. I'm just going to write it once. So they're all going to cross. The y-intercept, put in 0 for x and solve it. So I get 1 times negative 1 times negative 3 when I plug in 0. That gives me 3. So I'm going to start there. I hope I have enough room here. I may not. So we're going to see. If not, I'm going into my work. It'll be okay. So 1, negative 1, and 3. And the y-intercept is 3. So we have it. We have a point in between one of our intercepts, right? So that's a turning point. There's another one right here we need to plug in. So that number's at 2. So I'm going to plug 2 in. This might be like really way off. Yeah, we'll see. So I'm going to plug 2 in. Yeah, it's going to be a big number. So 2 plus 1 is 3, and 3 cubed is 27. And it'll end up being negative 27. I'm not counting down to negative 27. It's down there. I'm going to put it like right here. And I'm going to say, hey, that's negative 27. I know the right end goes up, the left end goes down, and that turning point right there is negative 27. And that's okay. It's not quite the scale. It's going to be okay. So the max, the relative maximum is here at 0 and 3, and the minimum was way down there, which is at 2 and negative 27 that we got here. All right, next one. What number are we at? 7, right? All right, 7. So we have x plus 4, x plus 2, x minus 2. The more we do these, right, we get into a bit of a rhythm, right, how to do it. So first the power term and end behavior. So x times x times x. That means the right end goes up and the left end goes down. So the right end up, left end down, intercepts. So our x-intercepts at -4, -2, and +2. They all are odd exponents, so all of them are going to cross. The y-intercept, if I plug in 0, 0 plus 4, 0 plus 2, 0 take away 2, 8 times -2, that's -16. I'm going to make the scale better for me. Here's what I mean. So the x are at -4, -2, and 2. I'm going to count by, well, let me find what the numbers are first. Then I'll change the scale. So this is going up to the right, down to the left. So I need to plug in -3 to see what the turning point is there at -3. So -3 plus 4, that's 1. -3 plus 2, that's -1. -3, -2, that's -5. So that's 5. That's not bad to put on the graph. We already put 0 on. If I plugged in -1, -1 plus 4 is 3. -1 plus 2 is 1. -1 and -2 is -3. So that gives me -9. I'll do it one more time here. +1. So 1 plus 4 is 5. 1 plus 2 is 3. And then 1 take away 2 is -1. So I get -15. So -16 is the lowest point there. So I'm going to count by 2's to go down there. So this is going to be -2, -4, -8, -12, and there's -16 right there. So I just counted and changed the scale to fit my graph. So this is -16. 1 is -15, which is in the middle there. 1, -1 gave me -9. Right? No, that's -12, -10, -9 right here. Ignore that. So there's -9. And then 5, same scale. So this is 4. So 5's in the middle here. And then connect your pieces together, smooth and continuous. Through that point, I got it. There's your curve. This again has one relative max. This is the top turning point, which is at -3 and 5. And it has a relative minimum down here, which is at 0 and -16. If you want to, you could type in this into Desmos and see how the graph looks and all the turning points and how close it is. Number 8. Well, this one's a lot smaller and easier. So for number 8, power term, x times x, it's x squared. That means both ends are going up. So the right end and left end are going up. The intercepts. So -3 and 1, odd, so they cross at both. And then the y-intercept. If I plug in 0, 0 plus 3, 0 take away 1, so that's -3. So here's my graph. So I'm going to start with -3 and 1. And the y-intercept was at -3. So where's the low turning point? So if I plug in -1, -1 plus 3 is 2. Negative, negative 1, and negative 1 is negative 2. That's negative 4. If I plug in the next one, negative 2, negative 2 plus 3 is 1. Negative 2 and negative 1 is negative 3. That gives me negative 3. This looks like a parabola because it is a parabola. And that turning point that is actually an absolute minimum. And the reason I changed that word is because it's the lowest point of the graph. Relative means there's other points that are higher than or lower than it. Just in its area, it's small or big. Here, there's no other points lower than that. So an absolute min, we can also call it the vertex. And so that point is at negative 1 and negative 4. Next one, where are we at? Number 9. So we're going to follow the same pattern. So the power term, if we multiply it out, is 2x, which means the right end behavior, the right end goes up and the left end goes down. So the right end is up and the left end is down. The x, the intercepts, the x-intercept is at negative 1 and has an odd exponent, so it crosses. The y-intercept, if I plug in 0, 0 plus 1 is 1 times 2 is 2. And that's all we need. If you look carefully, there's no curves to this one because it's a line. So we have the y-intercept, the x-intercept. It crosses up to the right and down to the left. Because the degree is 1, it still has the same structure, right, of what we're doing. There are no turning points. So the graph does not turn. It goes up to the right, down to the left, has intercepts, and we graph it. Number 10. All right. So the power term, negative x squared times x times x. That's negative x to the 4th. That means both ends go down. Again, you can press pause. The intercepts. So we have an x-intercept at 0, and it's going to bounce. Negative 2, and it has an odd exponent, and so does negative 4. So both of those are going to cross because the exponent are odd. The y-intercept is 0. When you plug in 0, the answer is 0. And now we can graph this. Trying to make sure I have enough space for what the points are going to be. So put the intercepts on here. So it's 0 at negative 2 and negative 4. Know that both ends go down. So I'm going to plug in negative 1 to begin with. So negative 1 squared times negative 1. Be careful with order of operations. Negative 1 plus 2 and negative 1 plus 3. So if I put this all together, I get the answer negative 3. So I'll put that on there, negative 1, negative 3. Then I need to get the other one, which is going to be a little bit larger value, which is here between these intercepts, which is at negative 3. Again, go back, negative 3. Negative 3 plus 2, that's negative 1. Negative 3 plus 4, that's positive. So, order of operations, exponents first, 9. So it's negative 9 and negative. So that's positive 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's the graph. So we have a maximum, one we just found, which is at negative 3 and 9, and the minimum here, turning point, which is at negative 1, negative 3. Awesome. We have one more. Why not? I'm going to save some room here. So, this is the one, x minus 3, x minus 1, x plus 1, x plus 3. So I'm going to do it in the margin as much as I can. So the power term, if I go x times x times x times x, add the exponents, it's x to the fourth. So the right end is going and the left end is going up. So both ends go up with a positive power term and an even exponent. Intercepts, the x-intercepts are, there's a bunch of them, 3, 1, I'll do it like this, negative 3 and negative 1, order doesn't matter. All of them have odd exponents, so they actually cross at each one, they cross the axes. To find the y-intercept, you got to plug in 0, so 0 take away 3, 0 take away 1, 0 plus 1, and 0 plus 3. So I get positive, so a negative times a negative is positive 3, so this is 9. And now we can start our graph using that information. See, I have no idea how much room I need, so we'll see. So there's my axes, lots of room. 1, 2, 3, and 1. I probably have way too much room. Negative 1 and negative 3. We know the y-intercept's at 9. So 1, 2, 3, 4, 5, 6, 7, 8. So there's one turning point. I know the right and the left. Both ends are going up. So there they are. So what values do I need to find that I haven't found yet? So I need to find at 2. So I'm going to go back here. 2 take away 3. That's negative 1. 2 take away 1. 2 plus 1. And 2 plus 3. So that's negative 15. There it is. See, that's why I had that much room. So 2 gives me negative 15. I think if I plug in negative 2, I'm going to get the same answer, but let's see. So negative 2 take away 3 is negative 5. That's negative 3. That is negative 1 and 2. No, I'm not going to get the same answer. So make sure I have that right. So for negative 2, that's negative 5. That's negative 3. Oh, this last one's wrong. So negative 2 plus a negative 1. This one, it should be positive 1. So it is going to give me the same answer. So the same answer is negative 15. Always good to double check, right? So here, same spot right there, right? Let's see if I can expand so you can see the whole, look at this big long graph. There it is. So all the way, oh, keep going, keep going, keep going, keep going, keep going, keep going, keep going. Look at that skinny W. Beautiful. If I asked you for the max, the relative max, we have one right there at 0.9. If I ask you for the relative minimum, we actually have two of those. So we have one turning point, and if you want to be fancy, you can do this, or you can write it separately. So positive 2 and negative 15, negative 2 and negative 15. That's just a quick way to write both points at the same time. And that's it. So all those graphs are done. Let's look at the next part. So the next part is, if I give you a graph, zoom in. I'm having a hard time seeing it too. I'm going to zoom in so I can see the numbers. Will you focus for me? Beautiful. So what could that graph be? What am I looking for if I want to work backwards? So I see that it's going up to the right and down to the left. So the power term is positive and odd. I see 1, 2, 3. So if I was going to like look at the scale, this certainly looks like 1, -1, and -3. That's what I'd be guessing. 1, -1, and -3. Now if I'm working backwards, the actual equation, it's going to actually end up being x plus 3, x plus 1, and then x minus 1. So that the opposite number is inside for the factor. See that? Now I want you to type this into Desmos and see how I did. I'm not going to do it for you. All right, press pause. Here, if I look, this looks like 1, and this looks like -1. Do you see how they bounce? So, again, the opposite number, it bounces. The opposite number, it bounces. This is where I would guess what that equation would be. So type that in and see if it matches. Again, I'm looking where the intercepts are and if they bounce or cross over. So it bounces, so that we're going to change the sign. So it's x plus 2 squared because it bounces. 0, it crosses, so it's just x with a exponent of 1. And then the other one's at 1, it looks like. So positive 1 would be x minus 1. Again, it crosses over. So I would start with this and see if this graph matches this, or if I need to multiply the front number by something. But that's the foundation of this one. And the power term, everything matches, the end behavior. Oh boy, this one. Hard for me to see here. All right. So it's -1. So I'm going to make that +1 and it bounces. So I'm going to make +1 and it bounces. And then 0, that's just x, but it bounces. So I'm going to make it x squared. And then it crosses at +1, so change the sign, and I get x minus 1. So I get x squared, x plus 1 squared, and x minus 1. That has a power term of x to the 5th. So I think it matches. See if the graph of this matches. What am I looking for here? What do you think that is? I think it's 2 and -2. So change the sign, so it's, and then it bounces. And then change the sign, and it bounces. Now, I can see that the y-intercept's at 16, and that matches. So when you plug in 0, 2 squared times -2 squared is like 4 times 4, so it's 16. So I feel pretty good about that equation matching. All right, last one, you want to try? Look at the intercepts. Do they cross over or bounce? So I see -2, so I'm going to go positive. It crosses. I see +2, so I'm going to make it negative. I think that's 4, so I'm going to make it -4. And then I would type this in and see if it matches and how close it is. But could you work backwards if you needed to? Anyways, I'm super proud. Did you get to this question? I'm super proud of you. You're working hard at polynomials. All right, Mr. G Math. Till next time.